is everybody today? Tired? Not too much? Good. Right, so I won't waste your time, and I'm going to go straight to the point. So 50% of the software that we build is pointless. And that means that 50% of the features that we build, they either don't get used, or they are used, but they don't bring any value to the business at all, or they were relevant at the time we talked about them, but they're not relevant anymore once they go live. Also, 30% of our cost is spent to ship what we build. So imagine you buy a car, you pay 10,000 euro for that car, and then you have to pay 3,000 euro to actually get that car delivered to you. That's insane. That's how much it's costing shipping software. And also, the way that we work, we don't get to ask these questions to our customer, which is at the core of the collaboration. So within our teams, if we like it within our company, we can ask this question: what do you think about this thing I'm building? Do you think I'm moving in the right direction? Do you think it's okay? So we definitely do that within our team. You know, if we are agile and we collaborate, if we like it and we have a well-structured company, we can go and talk outside of our team as well. But we don't get to ask this question to our customers. So we lose that opportunity of building the right thing and getting their feedback. So it's all a disaster. But not to worry too much, because things like continuous delivery can help us with that, right? And today we're going to talk about what kind of things we can introduce in terms of processes and patterns and practices to help us to go to that goal, which is we want to reduce our time to market, so we want to be able to ship software faster, and not only software, but relevant software, the things that we make an impact and we actually produce value to the business. We actually want to quickly adapt to the changes in the market that we're operating in. We want to be able to enable to experimentation, so we have a process in place which enables us to bring an idea from misconception to be live and gathering feedback about that in a very short period of time. And also we want to create an awesome team. So teams that delivers quickly and at a sustainable pace, it's a team of happy people. Yeah. So who is this guy who's saying everything is falling apart and 50% of what we build is wrong? So I'm Domenico. So the most important thing about me is not what's on there, but it's the fact that I am Italian, and that's not because of my cooking skills, which are great, by the way, but it's because of my accent. So if you struggle to understand me a little bit, please let me know. I will be more than happy to repeat myself. Right. So what we're going to talk about today is first trying to get some of the themes and names right about things. So we're talking about what's continuous integration, what's continuous deployment, what is continuous delivery, and then how to get there. If you want to start the journey towards continuous delivery, what are the key steps then from tomorrow you can take in your company to start your journey? So one of the caveats is that each of these topics is probably will require its own talk. So the aim of this talk is to try to give you hint and key steps to start with, but then I think you should go and try to have a more deeper knowledge about each one of those. Right. So continuous integration, what is that? So if you look on Google and you look continuous delivery, you will find many different things, and often continuous deployment, delivery, integration, they are mixed up, and most of you think they are the same thing. So actually they're very different things. So continuous integration is the act of integrating the code that you're writing, the software that you're building, with everybody else's code very, very frequently. And I'm going to go into details about what that means in reality. And continuous deployment is actually the ability of automatically somehow being able to deploy that integrated code, so the code you just integrated, on an environment, on a test environment. And also have a reasonable way of deploying this code live in some sort of production environment, yeah, for your clients to actually start using that. Then continuous delivery actually is the ability to ship new value, new features to our clients easily and fast, and at any given point in time. This is key. At any time, I should be able to produce and ship value to my clients. But let's try to understand what easily and quickly means. What does it mean actually in reality? So it means that you should be able to ship your code, your new version of software, to a production environment in a matter of minutes, not hours, not days, minutes. You should be able to be confident that whatever you're shipping it's working. And by working, I mean has passed a very well-defined suite of tests, which has been carefully agreed by the whole team. And we're going to go a little bit more in detail, so what that means later. And it should be able, this is very important, you should be able to collect immediately key information, key metrics about the new version of the software you just deployed. How well is performing? Is there a bug? Do I need to roll back? Which leads me to the next point. You need to be able to roll back to the previous version in a matter of minutes. And that has to be an automated kind of process. That enables you for experimentation. So actually going back to the first point, I'm trying to bring some clarity on what continuous delivery is. Really, for me, is just the result of being able to do continuous integration, in the true sense of it, continuous deployment. So if you do these two things together, they give you continuous delivery. You don't have to go all the way towards continuous delivery. If you start only doing continuous integration, you will get some value. If you then do continuous deployment, you get more value. And then at the end, you can start thinking about continuous delivery as well. So your release pipeline, and this is not just in terms of code, but it's more about how you would evolve your product, from a business and product perspective as well, should look something like that. You should aim to very, very frequent releases of small incremental changes. Yeah, that helps you to minimize also the risk of release. And there's by definition, moving a small thing is much easier than moving a big thing. Yeah, do you agree with that? Good. Right. A couple more caveats. Continuous delivery is not for every business. There are businesses where bringing in the effort of continuous delivery does not make much sense. If you work in an environment where, I don't want to say old banks or old public sector, where you produce some software, you give this software to somebody which is outside of control of your company, they will do 3 months of testing on their own and then they will try to ship it, then there is no point of trying to bring in any of this technique. It's just a waste effort. It's a cultural change. So actually, the techniques related to software development and coding and architecting about continuous delivery, it's a small part of what you need to do in order to really embrace continuous delivery. It's more of a process change. It's a mindset that needs to be embraced by a large part of the organization in order for actually to be effective. It's going to take time. In any company or organization of a reasonable size, which has been around for a while, it's going to take a year at least, if you do right. And then it's gonna be very complicated. So, how do we get there? So, what are the key steps that we can try to start to implement because we want to start doing continuous delivery? So, first thing, you need to kill the monolith. So if you have a monolithic application, a monolithic solution, a monolithic system, you can do continuous delivery, but it's going to be super, super hard. And I would advise you that you put your effort first in try to break the monolith and then try to start your continuous integration and delivery journey. We're not going to talk about how to kill the monolith. That's a topic on its own, and we could spend hours and hours talking about it, but be aware that if you are in a monolithic situation, you need to deal with that first. Now, we're going to talk about what are the things that we can do to enable continuous integration and what it means, how do we enable continuous deployment, and then what are the process that we need to change and how we need to structure our team in such a way that we can actually benefit from the values of continuous delivery. So, continuous integration. So what continuous integration really means is frequently, multiple times a day, you are integrating your code, so the code that you're writing with everybody else's code, on the master branch, on the main branch, on the branch that goes into production. Yeah. If you're not doing it, that's not continuous integration. If you're doing feature branching, even if they leave for a day or two, you're not doing continuous integration. So I've asked some question to some people saying, are you in a continuous integration environment? And people say to me, yes, of course. We have TeamCity, we have Jenkins, we do feature branching for a week, but we build everything on our continuous integration too. So we're doing continuous integration. That's not. You're just building your branch somewhere else. Now, I wish that probably most of these tools that won't be called continuous integration tools because they're not. They're really build tools that build pipeline and produce an artifact. So continuous integration, you have to work on master. You have to integrate with everybody else's code all the time. And there is really only one way of doing it, and you have to learn it the hard way. There is no much else you can do, and that's doing trunk-based development. Yeah, and what that means is that we do not do feature branching. We work on a new feature. We work on changing an existing feature. We write that code directly on master. Yeah, so trunk-based development is very hard. Is probably one of the hardest things to do because it also requires a way of changing the way that we write our code in such a way it can be integrated all the time, it can be shipped all the time, right? And so the question I always have is, people say to me, but how do I do that if I'm going to rewrite, a core part of the system? It's going to take me days. How can I commit that code? There are techniques that we can use to mitigate that, and I'm going to show you them in a minute. Right. So in order to do trunk-based development, you have to move away from the pull request model. Yeah. So I don't understand why pull requests became so popular into the software development community, into the private sector. So I do understand why it's a good model for open source project, people that don't know each other, they don't work together, but I don't understand what is the requirement behind the fact that I write some code and then another 10 people needs to look at my code within my company, people that I should know, to try to approve it. So how many of you ends up spend at least a few hours every day going through a pull request, handling all the comments because just you need to rename something? Well, a few of you. So all of us, you're very lucky. So what is the reason behind the pull request? I'm asking people, why do you need a pull request? Why people cannot just commit to master? And most of the time, the answer is because there is a lack of trust. I don't trust this junior developer to go and commit in master and ship this thing in production. I don't know how he or she, whether they will code well. So do pair programming. So work with that person. You can learn from each other, build quality in from the start. So try to collaborate, use pair programming over the pull request model. You save a lot of time. And then another thing is, back to the question before, is how do I write and integrate half-implemented feature? How can I do that? How can I present that to my customer? So the answer here is use feature toggle. So feature toggle is a great way to abstract your new code behind the configuration value. So you can have some new code which is halfway done, it's not quite working. So the code is that is integrated with everybody else's code, but nobody can see it. It's behind a feature toggle, and you can switch it on and on based on different environment to test how things are going. And the other thing that I think is this is the main thing that I would like you to learn today is branching by abstraction over feature branch. So let's learn how, instead of creating a new branch every time, work on that branch for a week and then spending another week try to merge it back because everybody has renamed everything in the meantime, as they should do all the time. Let's use feature branching as a different mechanism as opposed to branching by abstraction as opposed to feature branching. So what is that? How does that work? So let's imagine that I have a component, so a library, and I have a bunch of usages of this library in my system, and I want to completely change how the library works, right? But it's quite a complicated piece of code. It's going to take me some time. It's not something I can do in a matter of hours. Therefore, I cannot commit a fully functioning version of the new code into master. So I'm going to do that. In the old days, we will then create a feature branch, create a new implementation, finish it off, everything, and then merge it back with all the pain that it brings. So what branching by abstraction means instead is that saying that let's create an abstraction on top of that. So let's abstract the piece of code that we want to change. Yeah, and by abstraction here, I'm not just talking about interfaces, but try to put that thing that I want to change behind something which can have different implementation. I can have a mechanism to my code to then branch across these two different implementations based on some configuration values, for instance. So the idea is that you create an abstraction on top of the existing implementation. You will gradually point all the all the usages of the system towards that abstraction, and then at that point behind the scene you can start creating a new implementation of that. That code also gets committed all the time, nobody's using it. When you're ready, then you switch the abstraction to use the new code. Yeah, and then at that point you can decide, do I want to keep this abstraction because it's useful, or no, I don't need it anymore, I'm going to remove that abstraction, and then I can switch back all the clients to work directly with this new implementation. Yeah, so we shifted from a model of using a different branch as the way of diverging and abstracting to trying to create an abstraction in the system. Now, if you cannot find good spots of having an abstraction in your system, then you need to think about some refactoring, some bigger problem going on there. Right. The other thing that you definitely need to do in order to enable continuous integration is to define a testing strategy. A solid testing strategy, because people are going to commit much more often all the time to the day. You need to have a testing suite which is solid enough, which give you enough confidence that whatever you're about to deploy is going to work to some extent. You're never going to be 100% sure because there's too many variables in game, but you want to try to bring that confidence level, as up as you can, essentially. And a good one, it looks something like this. This is the Agile testing pyramid, I guess it's called, which basically says you want to have the majority of your system tested by tests that gives you a very quick feedback. So that will be unit test and integration test, and the smaller portion of those tests be about something that is a little bit slower to run, like the UI test, and the very, very, very small proportion by just manual tests or exploratory testing. Right. So in order to then, as I said, have continuous integration, you need to start implementing these things, yeah, and this is also a mindset shift. The next thing that you need to do is creating an integration pipeline. So this is what that continuous integration tool really is for. It's not to just integrating the code. So a good one is something like this. You change some code, you run your test locally, so you get some sort of confidence that whatever you're going to commit is going to work. Then you push something into the branch. You have your build tool, TeamCity or Jenkins, picking that up, building your new version of the software, running all the tests. If everything is fine and all the tests are green, you create an artifact. Yeah, so that's the outcome of the continuous integration pipeline. So the input is a code change. The outcome is an artifact that then can be deployed to an environment. Right. Continuous deployment. So we learn how to continuously integrate our code with everybody else's code. Now, how do we continuously deployment that artifact that we just created? First thing that you need to have is a deployment pipeline. So essentially, as you can see, this is very old. I don't know if Go is still a thing. It's a few years old. But I found it still as a good way to represent the deployment pipeline. And the interesting thing you see, that new package there is essential. I don't know if this can point. No, can't point. So that new package there is essentially is the output of the continuous integration pipeline, and it becomes the input for your continuous deployment pipeline. It becomes the trigger for it. And so you can see in here that then that package gets deployed to a dev environment. Some more tests are run on that environment. If they pass, they are deployed to the staging environment. More tests are run, and then you can then deploy to prod. The action of deploying to production environment, it can be manual, it can be automated. You can click a button. That's completely up to you. In order to do that, you need to have what's called smart packages. So what that means is within the package itself, there must be enough code or scripting or whatever you want to do, a Puppet script, Chef script, whatever is your tool of choice, so that package needs to know how to deploy itself on an environment. So try to bring the deployment knowledge and deployment concern with the package itself. That way, it's very easy. As you are evolving the package, the deployment pipeline for the package evolves with it. Yeah. So you may want to keep the configuration for specific environment outside because that's not really a deployment concern from a logic perspective. But try to keep the deployment logic with the package itself. It's going to make things much easier in the future. That's all good for the code. So we have an output of our continuous integration environment, goes in our continuous deployment pipeline. And that's all good for the software and the code. How about the database? So the database is the hardest thing. It's by far the hardest thing to continuous deploy somehow. So code is easy, state is very, very hard. Yeah. So in his previous talk, Chris was talking about, data migration and that kind of stuff. Those are painful. Those are painful things. So I don't know all the answer to how to fix this, but I know a few tricks that you can use to mitigate the problem. And one of them is, so treat your database schema as source code. Yeah. So when we write on code, we store the code as it looks today. So we do not store the delta or what it means from a given version to go to another version. Do the same for your database code. So you would save your code as creating objects, not as altering procedure, altering a function, or altering tables. Yeah. Treat it as a source code. And therefore, that allows you to then generate the migration script and the delta script. So you know how a given version of the software or the database should look like. Then you can use tooling to then say, okay, I want to now deploy this version to this environment. Tell me what I should do. And they will generate enough scripts to then migrate essentially. So that the point there is that those scripts are generated on a per release basis. They're not stored. They're not source code. They're not important for us to keep. And then always think about your database as something that should work with at least 2 versions of your software. The one that's previously deployed, yeah, and the next one. Because remember, one of the things that we want to do if we want to go towards continuous delivery is being able to release quickly, but also being able to roll back quite quickly. So we can roll back the code very quickly, and we need to make sure that the previous version of the code will work with the next version of the database, and vice versa. And so, in order to do that, spread breaking changes across multiple deployments. Yeah, do not remove columns in one go. Create a new column, rename it, and then another release to delete it. Right. Infrastructure. So we know how to deploy the code. We know how to deploy the database. What about the infrastructure? What about in cases where new version of the software also requires an infrastructure change, maybe because there is a new dependent service, I'm using a new caching mechanism, so I'm now depending on Redis, so I'm using a new queuing mechanism, I now depend on RabbitMQ. Try to have that infrastructure in a blue-green kind of deployment fashion, and kind of have infrastructure as a code. So try to have whatever infrastructure is needed for your software closer to the software as possible. Yeah. So there are a lot of tools. So I manage, I mentioned Puppet, Chef before. Terraform is a good orchestration. So these kind of things. But try to see the infrastructure, so the code and the infrastructure to support it as one thing. They will evolve. They will evolve together. They will help you. And then that a lot of tooling that helps you do that. What's one I already mentioned. Then one key thing, which we already talked about a bit, is to decouple deployment for release. So the delivery of a feature, so delivery of some value to your clients, is not about deployment. Yeah. So I may decide to deploy a new version of the software, but I'm not opening up new feature to my clients. Those could be behind a feature toggle. Yeah. So decoupling these 2 activities is very important, because if you think about it, deploying is a technology concern. So I need to know how to bring in a certain production environment a new version of the software. But whether I want to start switching, new feature for new clients or just for certain clients, that is out of the realm of just technology. So it's a wider scope. It's more in the product side of things. So decoupling that thing is a very powerful tool for you. And feature toggles, can really help you with that. Right. So enough with technology. What about the processes? So as I said, the tech bit it's just a small part of what continuous delivery is. The biggest part is the processes and the team structure to do that. So one thing that you have to do is you have to create what I call functional autonomous team. So as you grow, the best strategy is to try to have different teams which look after different parts of the system, and they are fully responsible for it. And they have enough skills within that team that can do everything. They can do a project end to end. So you want to try to minimize the cross team's permission, for instance. And this is key. So one of the things that we wanted to do, we want to enable experimentation. So we want to minimize the time that it takes. Oh, I have an idea. Let's try it out, to have that idea live, to do some experiment and gather feedback from our clients to understand, do you want to push this forward or no, it was a bad idea. You know, it was one of that 1/3 of bad ideas that I was mentioning this morning. In order to do that, you have to have that product authority in the team. So you have to have your product owner, product manager, whatever you want to call it, in the team, and they should be able to make the call. Yes, let's try this out. I don't need to go and ask for permission to a somebody higher, higher in the chain, essentially. QAs are embedded in the team. This is very important. So part of having that cross-functional team is everything is done in the team. You know, the testing. So I've seen model where the QAs, they live in their own team. So a team is very fast. You know, they build software, and then this software is handed over to a QA team, and then a month later they find a bug. They don't even know what the thing was about. They just basically click around and try to break it. It doesn't really work. So what you want to do is to try to build quality in, yeah, from the start, rather than trying to testing and finding defects at the end, because finding defects and fixing bugs at the end is very expensive for a bunch of reasons. One of that will be, you moved over from the thing, you don't really remember what it's about, try to switch context again. It's a very expensive thing, especially if they go in production. It's very expensive. You might even lose a lot of money with it. So try to build that quality in from the start. And then try to bring the QAs, or software development tests, or testers, or whatever you want to call it, closer to the code. Yeah. So they need to be able to understand enough about the architecture, the responsibility, the components involved to advise on the best testing strategy. So remember, one of the things that we said at the beginning is we want to create a testing strategy which is shared, yeah? And we want to, everybody which was part of getting that testing strategy, to value all the different tests at the same level. So I want QA to level the unit test. And the only way that they can do that is because they understand enough about the architecture of the system, so that they can agree that having some certain level of coverage on a given part of the system by unit test is good enough. Yeah. If they don't know what's in the box, they will always want to try to test outside of the box, which is very, very expensive, hard to maintain, and costly. As I said this already, avoid pull requests. Well, within your team, but especially across multiple teams. This is a very, very bad idea, right? You don't want to do that. Why do you want to do that? It's because so team, they tend to be working in an independent fashion, yeah. So they want to have their own iteration. They want to have their own release, and they want to be able to do whatever coding they need to do whatever testing, and then push that bit into production. The moment you start to have a pull request which goes across teams, then you start to need to coordinate with different teams' priority, different team knowledge, and always there is a lot of missing context, because a lot of knowledge is shared within the team, not necessarily with a different team. So the aim should be try to have that team being as autonomous as possible, and ask yourself a question: why do I need this cross-functional team kind of pull request model? What is the thing that I'm trying to gain? What is my objective? And if the answer is because within this team you don't have enough knowledge about the part of the system you're working on, or we don't think you're senior enough, and there is another team which is more senior, then restructure it. Bring that knowledge in. Work with those people. Yeah, this is not scalable as well. As the more you scale, the more teams you have, this is going to become a nightmare. And people are getting very frustrated because they can't go as fast as they would like, because they have a dependencies on other people which have different priorities. Right, so to summarize, the 3 key steps that you need to do if you want to do continuous delivery. So the first one, you need to enable continuous integration. And you can do this step by step. So you don't need to say tomorrow, okay, let's do continuous integration, all of it. You can start by saying, let's try to adopt trunk-based development. What are the things that we need to change in the way that we write code, in the way that we think about feature, to try to go into that direction? Then design your integration pipeline. This is different for every context. And think about what the artifacts should be. Once you got that, you can start thinking about the continuous deployment. And again, you can do this step by step, one small step at a time. So create your deployment pipeline. Try to bring that deployment knowledge within the artifact itself, so you can evolve it easily, and start thinking about infrastructure as a code. So the infrastructure to support the software, try to make it live with the software itself. And then adjust the process. And this is probably going to be the hardest bit, because most obviously the first two things, they require time and effort, but they could be self-contained activities within, the engineering department, the technology department. But this the process adjustment, the autonomous team, the authority in the team, that requires a significant shift in the mindset of the whole company. And there's been a lot of good talk, already. One was by Colin about saying, how do I influence people outside of, my team to bring them and having buy-in from them, essentially. So that would be the hardest bit for you. So to go back to the initial thing, so continuous delivery can help us with a lot of things. That's it, reduce our time to market. So we have an idea, we want to go to the market as soon as possible, while that idea is still relevant. It allows us to change and adapt very quickly to the change of the market we're operating in. Enables for experimentation. So we have an idea, quite quickly we can experiment on it and validate whether it's good or bad. And we're gonna have an awesome teams, because they're gonna see the result of their work constantly and bringing values to the business. So I want to close with a quote from Susan Pease from ThoughtWorks. So what she says is that continuous delivery doesn't mean that you have to ship in production new feature, every day, every minute. It just means that release needs to be a non-event. That's all it is. Thank you.
Thanks for great presentation. So let's move on to questions. Any questions? Yeah, we have a hand there.
Hi, thank you for a great presentation. I have a few questions for you. First of all, if one repository is used by different teams, for example, and both teams is using trunk-based development, so one team did something in master or trunk branch, and another team did the same, and second team want to deploy, but first team breaks something, how can they solve it?
Right. So that's a great question. So I don't need to repeat it. So it requires a very long answer, and I think there is a lot of angles to it. So one thing is, it go back a little bit to that monolithic model. So the bigger the branch is, the bigger the system is, and the more monolithic it is, the higher the chance of I have committed something which is going to break, something else that somebody else is working on. That chance is higher. So one of the things that you need to try to do is to try to split up the monolith, and in such a way that you have a distributed system where different branches, different part of the system are localized to a given area. So that's one thing. That said, even on a small branch, you can have that problem, right? I can commit something that probably another pair or another developer in my team is not going to integrate well with, and that's the answer to that. It's a more complicated one, it's a more long-term one. You need to build that testing strategy. So remember that the continuous integration pipeline that we've seen, a key step is I do not commit if I have not run my test locally. So you have to try to have a testing suite which you can run locally, which will give you fast feedback, which is going to give you the confidence that what you're about to commit is going to work with other people's code. So those are the two things, I think. So one is you break the monolith, so you reduce the size of the part of the system you work with, and then you can directly break with your code change. And the second one is you create a testing strategy which gives you confidence, and you can run that locally before you commit.
Thank you for an answer. And second question about pull request. We are using pull request for knowledge sharing.
So what?
Knowledge sharing. So when somebody is doing something and a lot of people knows about this repository, we are doing this pull request, everybody knows what's going on, and then everybody knows what was the changes. What's the best approach for this if not using pull requests?
Right. This is an interesting thing. So
Sorry, one more. Just I understand that code should be self-documented, so we don't use documentation source. So all comments are inside the code. So if guy didn't check the which changes was in code for last 2 weeks, so he don't know what was changed. So pull request getting up to date. Sorry, that's all the question.
No, absolutely. So the pull request one. I don't know if it's a personal thing, but I found it extremely complicated to even understand what's going on in a pull request and whether I should approve it or not. Because so I suddenly receive an email, there's this pull request for you. So I go in there, I can see some difference in the code. Yes, this interface name has changed, this piece of code has changed here, but I have no context whatsoever of why. I don't know why this changes here. I have no idea what is the objective, what they try to accomplish. So I will say that most of the time, because we want to commit often and all the time, our changes will be tiny. So probably if you look at any given change, it won't tell you much, and it's not even worth reviewing it in the sense that the change will be tiny. If I look at the bigger change, then I don't have the context. So I don't think that using the pull request model as a way of sharing the knowledge and telling people why you're doing it or why something has changed is very effective. If you're doing a significant change to your system where you think, I'm not just renaming a variable, I'm changing the way that we connect to the database, or I'm optimizing our caching model, I think a much more effective way of sharing the knowledge would be a lunch and learn, for example, where you give people context, say, this is what the problem I'm trying to solve, this is why I'm doing this is the option we evaluated, and this is what we did. Because mostly what happens when I have a pull request, I have no context whatsoever, and I start thinking about, because I don't know what were the decision behind, what were the reason behind the decision that were made, and then I start raising questions, why I've done this, why I've done that, whether that could have been solved much more effectively in a 5 minutes conversation or a 20 minutes lunch and learn. What was the last one?
Yeah, it was clarification, yeah,
okay,
of the question.
Okay, cool.
Thanks. Any more questions? No, we have one here. Any tools to manage feature toggles?
Yeah, there are a bunch of them. One that you can use is your deployment tool. So there are things like Go can do it. Things like Octopus deployment, if you're using it, can do it. Tools like Chef, which has the concept of environment configuration, can do it. There are other tools which allow also configuration to be changed at runtime. Things like Console from HashiCorp. It's a great tool that you can use for it. So there's a bunch of that.
Cool. Another question is about how to apply blue-green, again blue deployment to DB.
This is very interesting. So blue-green deployment is mostly applied for the code in the sense that I can have 2 versions of my software deployed at every given point in time, and then I decide to switch from one version to another, right? So the database is essentially, it's a single point of failure most of the time, right? So it goes back to the point of how do you do continuous deployment with database. So obviously blue-green deployment is not a technique that you can use there, but what you need to do is to essentially change your database in such a way that it works with multiple versions of your software. So it has to be working with the current version and the version that you want to deploy. So there was an interesting idea from a colleague of mine called Matt Thompson, and then he's basically trying to push for this idea of maybe we should look at the database as if it was a microservice on its own. And the contract between the database and the rest of the system is the schema. And so if you look at it that way, we don't want to break contracts, between services, and that will encourage us to think about a way of evolving the database, thinking as if the schema was the contract, so we don't want to break it. But yeah, I think the key there, you can't apply blue-green deployment, you have to spread breaking changes across multiple releases.
Okay, thanks. One more question. What actions could be made to decrease the number of unwanted wrong features? From
so I think, so I think the whole point of continuous delivery for me from a product business perspective is to try to mitigate and minimize the negative impact of that 50% of bad stuff, that 1/3 or 2/3 of bad ideas that we were talking about this morning. And that's, I think, for me, is done through, and through being able to enable experimentation. So we have an idea, we want to create the quickest MVP out of it that we can, put it out live for our clients to use, and from day one, as soon as we start thinking about MVP, think about what are the success metrics, what are the things that you're going to measure once that thing is live, and you're going to use that data to decide, I want to push this forward or not, this was a bad idea. So the shorten you can have that process, obviously the shorter that is, the minimal the impact will be of minimizing that 50% of waste essentially.
Cool, thanks. Any questions from here inside? No? Okay, let's move on. How to control DB changes?
Right.
When 2 or more programmers are working on the same package at the same time.
Interesting. So the data, if we look at database as a service, where the schema is the contract, essentially what we want to do is to create a continuous integration pipeline for the database. So one of the practical things that I've done in the past, and it's one of the thing that helps us the most is so create a pipeline where you are able to run tests against the database. What that means is you can run enough tests locally, which essentially will test the new schema of the database, which was currently live in terms of code and also database, and you will be able to generate the delta on the fly and simulate applying them to the production version. So you can tell quite early into your process whether you are evolving your database in such a way that it will be working in production or not. So the short answer there is a continuous integration pipeline for the database, obviously with different characteristics, with the aim of trying to have tests that you can run, which will test a new version of the database with the one in production.
Thanks. And I guess the last question, again about database. Is database code still in CI if you suggest to have a clean 2 version?
Right, so yes, so the database code lives with the software itself, it evolves with the software. So I'm not suggesting actually to have 2 versions of the database code. What I'm suggesting is any version of the database code needs to be able to work with 2 versions of the software. So that's a slightly different thing. So we still have 1 version in master of the database, and that version, as soon as we deploy in production, that needs to be able to work with the current version of the software and the next version. So I deploy the database first, the same version of the software is still there, then I switch to the new version, everything works, then I roll back because it's broken. I do not roll back the database at that point, it still works with the old version of the software. I can then start rolling back the database as well. But what I'm suggesting is the database works with 2 versions of the software, not having 2 different versions of the DB itself.
Thanks.
Cool.
So I've already run ratings, but it still doesn't visible on there. But okay. So thank you for your presentation. Small gift from Agile Lithuania. Thanks.
Thank you. Bye. Thanks.